September 12, 2025. The sky delivers a shock unlike anything we've seen in decades. A colossal object, its tail 5 times wider than the full moon, bursts into view, blazing across the inner solar system with a confidence that feels almost deliberate. At nearly the same moment, another visitor, 3I Atlas, surges in from the opposite side of the sky. Their trajectories collide in time and space, converging on the Sun within a 10-day window that leaves Earth's telescopes blinded by solar glare. Nickel signatures where iron should dominate, sudden bursts of acceleration, and micropulses in luminous tails. These are not the fingerprints of ordinary comets. Are we witnessing rare cosmic coincidences, or the movements of something mission-driven, written into the fabric of the stars long before we ever looked up? September 12, 2025 began like any other day on my calendar, until the instruments refused to agree with the past. A ripple of numbers crossed my screen, not dramatic at first, just enough to make me stop scrolling. Then, the plots stacked. Brightness rising too fast, morphology too bold, geometry too convenient. Something large had stepped into the inner solar system, and, if the early frames were trustworthy, it was writing its name with a tail so long it mocked our usual scales. I felt that familiar mix, the cool habits of a scientist bracing the door while wonder hammers from the other side. Welcome to Velocity of Comets. I'm your reporter, and tonight, you and I are going to stand at the window together. No hype, no hand-waving. Only the thrill that comes when raw data starts behaving like a story. The first confirmations came fast. The SWAN instrument flagged a new object so bright the amateurs could join the hunt before the ink dried on internal alerts. Within hours, my inbox filled with hemisphere-spanning images, an Australian backyard observatory recording a luminous blade that nearly outran the camera's field, a Chilean ridge catching the tail at a low angle, the sky barely dark, the streak already insistent. Separate teams measured the angular extent, 2.5 degrees, roughly 5 moon widths across. I've taught entire semesters on why tails are deceptive, why projection angles lie, why early curves mislead. This one stared back, unblinking. I sketched the numbers in my notebook the way I always do, pen chewing into the paper. Magnitude around 7 and climbing, tail length outpacing most recent finds, sky position threading near the Sun where we hate to look. Then I flipped to the second page and wrote a single line in thick letters. There are 2. Because this was not just about the newcomer christened C2025 R2 SWAN. 3I Atlas was already inbound from a different quarter of the sky, behaving in ways that make a cautious person reach for more coffee and a clean spreadsheet. 2 bright visitors, steeply inclined paths, perihelia circling the same week, and a solar glare corridor timed to blind our best instruments. Coincidence is allowed in the cosmos, but sometimes coincidence feels like choreography. Before we lean into interpretation, come stand with me inside the machine rooms. Hubble, majestic as ever, carries a hard sun avoidance angle. Webb, more distant and thermally fussy, obeys an even stricter pointing cone. NASA's Deep Space Network plots passes months out. You don't just pivot billion-dollar assets to chase a surprise unless the geometry plays nice. ESA mission planners juggle similar constraints. MIT spectroscopists ping me about pre-conjunction windows. They're short, but not non-existent. SpaceX doesn't aim Starlink cameras at comets, but their star trackers still see the sky. Even peripheral logs can hint at transient brightness. This is how modern astronomy breathes. Flagship observatories breathing in long, careful inhalations, while a million small lungs, the amateurs, universities, small domes on hillsides, exhale continuous vigilance. Back in the data, 2 tracks emerged, motion and metabolism. Motion first. I projected both trajectories onto a star map. Swan curling in from the Aquarius side, Atlas from near Sagittarius. On paper, their approach vectors sit a wide quarter of the sky apart. Yet the timestamps crowd. Perihelion for Atlas around October 17th, for Swan around the 20th. Solar distances differing by tens of millions of kilometers. A sneeze in solar terms, closer than Mars ever gets to Earth. Add the blackout window, roughly October 8th to 18th, when sunlight yanks the curtain across our optical stage. That window isn't malice, it's physics. But it slices the story exactly at the chapter break. If you're feeling the tingle, you're not alone. Now metabolism, what these bodies shed when they warm. With 3I Atlas, early spectroscopic drafts showed CO2 lines towering over H2O, which is rare but not unheard of for cold provenance visitors. Harder to swallow were metallic hints that leaned nickel-heavy, iron light. Is that an artifact of calibration drift, telluric correction, instrument response? Entire careers are built on getting those details right, and several labs immediately tried to break the result, exactly as they should. Meanwhile, photometry suggested something stranger. 3 discrete accelerations on a regular cadence, roughly 2 weeks apart, with noticeable shifts in color slope coinciding with each step. Not the smooth exhale of sunlight uncorking ice, but a staircase. Non-gravitational accelerations happen. Jets twist and tug on tumbling nuclei. But repetition with a beat makes even the most jaded dynamicist cock an eyebrow. If it's rotation aliasing with solar heating, we'll find the period. If it's geometry whispering vent alignment, we'll model the torque. If it's something else, it will keep time until we admit we hear it. Swan is a different personality, a cathedral of brightness, rather than a puzzle of pulses. Its tail, bright and wild, still showed hints of microkinks that repeated like a tiny drummer behind a symphony, enough for some observers to annotate possible micropulses on their charts. It may be nothing more exotic than a large coherent nucleus, a handful of persistent jets, and the solar wind flickering like a restless hand across a candle flame. But small regularities in big, chaotic systems are what teach you to listen closer. I've learned from NASA colleagues to write 2 words in the margin when patterns tempt me. Prove it. The speculation mills started anyway. Of course they did. Nickel-cobalt hull, plasma envelope, fortress. I understand the allure. I also remember the bruises from past overreaches. Reflectance that looks metallic can be a patch of high albedo rotating just so. A halo that reads shield can be forward scattering from fine dust in a sweet spot of phase angle. A curve that feels like thrust can be jets finding the rhythm of rotation. ESA friends remind me kindly to extinguish campfires before they become wildfires. The rules are simple. Describe what is measured, name what is modeled, flag what is guessed, and never let your metaphors outrun your math. But let me admit what keeps me awake. The geometry still hums. 2 steeply inclined orbits, a near-synchronous sweep through the solar neighborhood, a period of enforced visual silence as they round the sun, a long-period estimate for Swan on the order of 22,000 years, long enough to have swung past when ice gripped the north and humans were carving the first calendars in stone. None of that proves intent. All of it makes the hair on my arms stand up. Meanwhile, the people who cannot wait, the best kind of impatient, are working anyway. Bill Gray style, distributed orbit networks spin up spreadsheets and Git repos. Backyard scopes are tuned to low-elevation windows at dawn and dusk, where glare is hateful but not absolute. A small radio dish in Portugal records narrowband noise near plausible outgassing lines, not because anyone expects a message, but because spectra can hide in static. University groups coordinate negative observations to tighten constraints. Even a missed detection with a clean upper limit can steer models. The Deep Space Network keeps its schedules conservative. Mars orbiters and outer planet craft won't risk assets for rumor. That's not darkness, that's discipline. The light comes from the edges, those long, stubborn time series amateurs build when institutional telescopes are protecting themselves from the sun. In the middle of this, I pause and look inward. Why does this matter? Because this is what we do at our best. We hold curiosity and caution in the same hand. We name the astonishment, two luminous visitors walking the same corridor, without letting astonishment become claim. We invite every credible hypothesis into the room. Rare natural choreography, outgassing driven by volatile stratigraphy and spin, complex rotation states, solar wind coupling, or, yes, the possibility, stated as possibility, that we are watching mission-like behavior from objects not born here. We don't slap labels, we build ladders. Astrometry first, photometry next, spectra, morphology, dynamics. We climb only when the rung below holds. If you stay with me through this blackout and back into the light, here's what I'll do for you. I'll show you brightness curves without the makeup, no smoothing that hides the warts. I'll walk you through spectra and tell you where the confidence bars bite. I'll compare orbital fits against independent solvers and flag residuals that refuse to shrink. I'll bring in voices from NASA's Planetary Science Division, ESA's Comet teams, MIT labs, the Hubble and Webb operations folks, and anyone who can illuminate rather than inflame. If SpaceX telemetry or DSN schedules brush against our story, I'll fold them in with context, not drama. And then, when the glare slackens and the object step back onto a darker stage, we'll see what changed. Did Atlas keep its metronome? Did Swan's microkinks keep time? Did either object shed mass, or shrug off the sun like a swimmer gliding past a buoy? The answers won't arrive as headlines. They'll arrive as lines on charts that only become extraordinary when you lay them side by side and feel the alignment click. If that sounds like the kind of journey you want, slow, careful, thrilling in the way real discoveries are, then stay near. Consider subscribing, not as a transaction, but as a promise that we'll walk this corridor together. The sky is writing something in the margin next to the sun. We'll learn to read it, not by shouting, but by listening. I want you to picture the scene. Inside the control rooms at NASA, ESA, and MIT, clocks tick toward October, and every scientist knows the same frustrating truth. The sun is about to pull the curtain. From October 8th through the 18th, our most powerful telescopes, Hubble, Webb, ground-based giants in Chile and Spain, are blinded by solar glare. It's the worst possible timing, because just as the blackout begins, two of the strangest objects of the decade are sweeping, within days of each other, past the sun. Swan, with a tail 5 moons wide, and 3I Atlas, with its mysterious nickel-heavy spectrum and stepwise accelerations, converge in a narrow corridor we can't directly watch. If the universe were writing suspense, it could hardly have chosen better. I've seen a lot of sky in my career, but the data flowing in before that blackout felt like puzzle pieces from two different boxes, somehow fitting together. Let's start with Atlas. Spectroscopic teams, independent, serious groups, not late-night forums, picked up a signal that made people gasp. Nickel lines without the usual iron companions. That's like baking a cake with all the sugar but no flour. Every instinct in me says, check calibration, check atmosphere, check everything. And they did. MIT, The Atlas SpaceX Consortium, the Ibero network, they threw every correction pipeline at it. Yet the nickel stubbornly glowed. Meanwhile, the CO2 signature roared 5 times louder than water vapor. Natural, perhaps, for a cold interstellar origin, but paired with 3 sudden accelerations, each 2 weeks apart, each coinciding with sharp color changes in the tail, the picture tilts. These weren't smooth sublimation curves. They were jolts, like something giving itself a shove. I mapped those jolts against the solar wind charts from NASA's Solar Dynamics Observatory. There were gusts, yes, but the timing was off, too regular, too clipped. Natural vents can mimic burns, but they rarely keep a drummer's beat. To match the accelerations,
You'd need bursts delivering power on the order of 10 gigawatts, 10 nuclear plants firing in the belly of an icy rock.
That's when even the most skeptical colleagues shifted uncomfortably in their chairs. And then there's SWAN. Where Atlas is twitchy and nimble, SWAN is colossal, deliberate, terrifying in scale. A tail visible in binoculars, photometry suggesting a nucleus pumping out as much energy as Earth's entire power grid. When amateur astronomers trained their scopes, they saw more than light. They saw micropulses in tail direction, tiny rhythmic nudges, as though course corrections were stitched into the plasma itself. Natural models exist: rotational shedding, dust-to-gas modulation, solar wind sculpting. But when a pulse repeats with eerie consistency, the word control whispers at the edge of the mind. Add to that the reflectance oddities, metallic glints, a silvery halo, signatures that some call nickel-cobalt alloys, others call forward scattering. I've spent years warning against the seduction of science fiction in our data, but the chatter in professional channels is undeniable. SWAN doesn't just look big, it looks engineered, fortified, shielded, perhaps even armored. Astronomers started calling it the Fortress, not because they proved it, but because their metaphors betrayed their awe. Now stitch the geometry together. 2 objects from opposite corners of the sky, reaching perihelion 3 days apart at nearly identical solar distances. SWAN, slow, massive, cycling back every 22,554 years. A return interval that brushes the edge of the last ice age. Atlas, hyperbolic, possibly interstellar, twitching with gigawatt thrusts. 1 tank, 1 scout, and both arriving when Earth's instruments are forced to look away. The odds are not 0, but they are close enough to impossible that even the most conservative orbital dynamicists began using phrases like statistically vanishing. That's why whispers of mission profiles began creeping into scientific conversations. A refueling run at the Sun, the ultimate power node. A rendezvous and repair operation, SWAN as the carrier, Atlas as the agile drone. Or the audit chain theory. Oumuamua in 2017, Atlas now, SWAN as the reinforced emissary. Escalating probes, sent in sequence, responding to a century of human radio leakage. These are only hypotheses, unproven, provocative, dangerous to assert as fact. But they are now on the table because the evidence refuses to settle neatly into ordinary bins. Meanwhile, in the silence of official blackout orders, a parallel drama unfolds. Amateur astronomers, small university labs, even backyard radio dishes all step up. Bill Gray rallies his distributed orbit network, encouraging everyone to log every flicker. The Ibero Collective in Spain wires together wide-field cameras. Leaked chatter hints at weather satellites being repurposed to watch the margins of glare. While NASA and ESA enforce operational caution, the grassroots refuse to let the blackout be total. It feels like a quiet rebellion. The sky belongs to everyone, and if the big domes can't look, the small domes will. This is what I love most about moments like this. Science becomes communal. The mystery is too big for one observatory. too important for one nation. When two anomalous visitors slice across the same corridor, silence is not an option. Data is currency, and every photon counts. So here we are, two bodies, one twitching with metronome-like thrusts, the other blazing like a fortress from the Ice Age, passing the sun together, while we're forced to squint from the sidelines. Some will say coincidence, some will say choreography. Both sides will wait for the post-blackout reveal. But I'll tell you this. The stakes are real. If Atlas pulses again on its 2-week rhythm, that will be a revelation. If Swan's microthrusts keep perfect time, that will be another. If either deviates, dims, fractures, vanishes, we'll be forced to rewrite not just their story, but the rules of cometary behavior itself. That's why, even in silence, we listen harder. Because sometimes the universe saves its most important answers for when we can't quite see. And when the glare lifts, the first frames will matter more than 1,000 headlines. Stay with me. The blackout is not the end, it's the pause before revelation. And when the light returns, we'll read the sky together. I've stood under night skies when meteors broke across the heavens, and for a breath, the line between fear and wonder dissolved. That's exactly the feeling these two objects, Swan and 3i Atlas, demand of us now. Not because they threaten us directly, but because they are rewriting the limits of what we thought the solar system would allow. The blackout is over. Our telescopes are blinking back to life, and the first glimpses we're recovering will either confirm our boldest hypotheses or remind us that nature still has tricks we haven't catalogued. Let's begin with the tally. Atlas, the twitching wanderer, recorded 3 stepwise accelerations before disappearing behind the sun. Will it reappear with a 4th? If so, the regularity is undeniable. Jetting alone doesn't explain a cadence that crisp. Natural models exist, rotational precession, vent exposure, volatile layering, but they strain under the gigawatt energy estimates. If it pulses again, and if the color shifts repeat, we'll have to confront the uncomfortable truth that our definitions of natural have been too narrow. Then there's Swan. Before blackout, it strutted across the sky with a tail visible to the naked eye, micropulses in its brightness, and whispers of metallic glints. Did it survive perihelion intact? Did it fracture? Did its pulses continue in perfect rhythm while hidden in the glare? If it emerges brighter, with tail direction still modulating like a controlled plasma plume, then the fortress nickname will feel less like metaphor and more like observation. But if it emerges dimmed, battered by the sun, then we'll know even the mightiest comet-like objects still bow to physics. Either outcome is extraordinary. Now let's talk risks. Real ones. Not cinematic doomsday scenarios, but the practical consequences our spacecraft engineers sweat over. Every time a body this active passes through the inner solar system, dust and debris can seed meteor streams. Mars orbiters, Earth satellites, even solar probes like Parker have to account for enhanced particle environments. Navigators model trajectories against possible debris tails, adjusting spacecraft attitudes to reduce cross-section exposure. It's quiet, unsung work, but it's where science meets stewardship. These aren't hypothetical dangers, they're operational realities. And if Swan's dust yield proves as immense as its tail suggests, the solar system's traffic controllers will be updating risk maps for years. But what about the deeper question? Why now? Why together? That's where the controversy sharpens. Agencies have been cautious, issuing measured statements, reminding us that coincidence, though rare, is not impossible. Yet behind closed doors, some researchers admit what they can't quite say on record. The geometry feels engineered. Not proof, not consensus, but suspicion. And when suspicion meets silence, blackout orders, delayed data releases, memos that discourage speculation, the vacuum fills itself with rumor. That's how the words rendezvous and mission leap from podcasts into academic seminars. I've heard whispers of 3 scenarios circulating in both professional and amateur circles. First, the refueling hypothesis. Swan and Atlas using the Sun as a pit stop, tapping energy wells the way our probes use gravitational assists. Second, the repair scenario. Atlas as a nimble drone rendezvousing with a carrier-class Swan, perhaps to exchange data or recover assets. Third, the audit chain theory. That Oumuamua in 2017, then Atlas, and now Swan represent a sequence of increasingly complex probes, each a response to our radio leakage, each stepping closer in scale and purpose. None of these are proven. All of them raise our collective eyebrows, and all of them sharpen the same fundamental question. If this is a mission, what's the mission for? Here, the philosophical weight lands heavy, because even if we were to confirm that these objects are probes, engineered, mission-driven, that doesn't guarantee their makers still exist. Intelligence, like stars, can die. Civilizations can fail. What if these are messengers from a people already extinct, machines following ancient programming across gulfs of time? What if Fortress and Scout aren't threats, but refugees, gathering energy to continue their blind journey away from some catastrophe we can't imagine? The idea chills me, but not because it spells doom. It chills me because it frames intelligence itself as fragile. If it happened once, it can happen again. To them, to us. That's why this moment matters more than headlines. Beyond the speculation, beyond the awe, lies a mirror. Swan and Atlas remind us that intelligence is not guaranteed to endure, that survival is not automatic. Whether natural or artificial, these visitors warn us. The cosmos is harsh, and only vigilance keeps a species alive. And yet, there's something profoundly human in how we've met the blackout. Not with silence, but with collaboration. Backyard astronomers, citizen networks, open-source trackers, ordinary people refused to let the story vanish. While agencies stayed cautious, humanity as a whole leaned forward. We measured, we listened, we shared. This too, hashed meta, NES, SEX 0.05, is part of the lesson, that survival in a universe of anomalies depends on cooperation, not secrecy. So, as I stand here tonight, I'm struck by a paradox. Maybe Swan and Atlas are nothing more than rare, spectacular comets whose timing happened to converge. Or maybe they are artifacts, machines on missions older than our pyramids. Either way, the meaning is the same. We are paying attention. We are learning to notice, and that is how civilizations endure. The blackout has ended, but the questions have only grown brighter. What will we find in the cadence of Atlas's next steps? What secrets hide in the shimmer of Swan's tail? And most importantly, are we ready for the answers? Whatever they may be, stay with me. This journey isn't finished. Together, we'll face what the cosmos sends our way, with awe, with rigor, and with the curiosity that defines us as human. The journey of Swan and 3i Atlas is more than an astronomical event. It is a story about the limits of chance, the persistence of mystery, and the fragility of intelligence itself. Two objects from opposite ends of the sky entered the inner solar system together, their perihelia separated by just 3 days, their solar distances tighter than the orbit of Mars. Atlas flickered like a restless scout, pulsing forward in jolts of energy that defy smooth natural curves. Swan blazed like a fortress from deep time, carrying a tail so vast it rivaled the greatest comets in human memory. For some, the evidence still speaks of rare physics, volatile layering, chaotic jets, and dust sculpted by solar wind. For others, the cadence of acceleration and the metallic glints whisper of design, of missions older than our civilizations. The truth remains unsettled. But what matters most is not which hypothesis wins. It is that humanity is watching closely enough to ask the question. I feel humbled, even haunted, by the thought that intelligence, wherever it arises, may not be immortal. If other civilizations once built machines that now pass silently through our skies, they may be long gone, their voices extinguished, their messengers reduced to relics. That possibility isn't cause for despair. It is a reminder. Our survival is not guaranteed. Our vigilance, our curiosity, our willingness to work together, that is what will keep us here. So as Swan and Atlas blaze onward, leaving their signatures in our instruments and imaginations, I leave you with a simple question. What if the rarest message in the universe isn't that we are not alone, but that intelligence itself is fragile, fleeting, and must be guarded? Subscribe so we can continue this cosmic journey together and face the next revelation as one.